Okay, so today is solving 6.12, solving rational equations, part 2. So in this mini lesson, I'm basically going to go through 3 different examples that are all slightly different, but it's really just the same steps as last class. So if you feel comfortable, you could just go straight to the practice. However, something that I would encourage you to watch is my second example. So if you kind of want to click through, fast forward, maybe watch at 1.5 speed, that's totally understandable. But basically I'm going to go through some different examples, okay? So first example that I want to show is when we have 2 different denominators. So let's say I have 1 minus 3 over x equals negative x over x plus 2. So in this case, we're still trying to get rid of the denominator. So what you want to do is you want to look at the first denominator that you see. In this case, it is x. So what I'm going to start doing is I'm going to start multiplying every term by x, right? And I'm going to simplify where I can, which is only just in the middle term. And so now I'm going to write out what I have left. And I'm going to kind of take some shortcuts now that we're more familiar, right? We multiply these. So 1 times x is 1x, and then minus 3 equals negative x squared over x plus 2. If you notice, I still have a denominator. So I'm going to do the same process now, but with this denominator. So I'm going to multiply every single term by x plus 2. And again, I'm going to simplify where I can, which is only just in the last term. So now I'm going to write everything out. So I have 1x parentheses x plus 2 minus 3 parentheses x plus 2 equals negative x squared. I'm going to distribute. So I'm going to have 1x squared plus 2x minus 3x minus 6 equals negative x squared. Again, since we have x squared, we need to move everything to one side. But before I do that, I forgot I can combine these 2 terms. So I'm going to write 1x squared minus 1x minus 6 equals negative x squared. And I'm going to now move this negative x squared to this side. When I do that, I'm going to have 2x squared minus 1x minus 6 equals 0. So again, we need to factor, but we're not going to use sum product rule because we have a number bigger than 1 here. So in this case, I need to use the AC method. Okay, remember the AC method is when you multiply the first and the last term, and you get 12. I'm going to find the factor pairs of 12 that give me negative 1. So I know factor pairs of 12 are 1 and 12, 2 and 6, and 3 and 4. I'm going to use 3 and 4. To get me negative 1, the 4 has to be negative, the 3 has to be positive. And if you remember, I now rewrite the equation. So I still have the 2x squared, but instead of negative 1x, I'm going to use my factor pair like this. And now I factor by grouping. So here I can take out a 1x. Here I can take out a negative 2. I'm taking out a negative because this is a minus sign in the middle. So if I factor out a 1x, I'm left with 2x plus 3, right? Because I'm dividing. I'm dividing 2x squared divided by 1x. And then I'm doing 3x divided by 1x. That's how I got this right here. And then I put my next GCF on the outside, negative 2. And again, negative 4 divided by negative 2 gives me 2x. And negative 6 divided by negative 2 gives me positive 3 equals 0. And then you notice I have my twinsies. So I'm going to put my twins in a parentheses. And I'm going to put my GCFs in the other. So I have 1x minus 2 equals 0. And then lastly, now to solve, right, set each parentheses equal to 0. So here I'm going to get x equals negative 3 over 2. And here I'm going to get x equals 2. Again, go back to the original problem. I know it was far up, but our denominators were x and x plus 2. So both of these solutions work because neither of them become 0. Okay? Now, I'm going to show you guys another example. Okay, so that was example 1. In example 2, what you'll notice is that sometimes you need to factor a denominator first. Okay, so in this case, let's say I have 7 over x minus 9 plus x plus 5 over x minus 1 equals 2 over x squared minus 10x plus 9. This denominator can be factored, so you gotta factor that first. So we're gonna find the factor pairs of 9, which are 1 and 9, 3 and 3. To give us negative 10, we're gonna use 1 and 9, and they both have to be negative. So I'm gonna rewrite this. So I'm gonna rewrite 7 over x minus 9 plus x plus 5 over x minus 1 equals 2 over x minus 1, x minus 9. Okay? So at this point, now, here's the thing. Hopefully this doesn't confuse you. You could multiply everything by x minus 9, right? Because that is technically the first denominator that you see, right? But if you notice, there's another denominator that will cancel out more things. This one right here. So instead of multiplying by x minus 9, I'm going to multiply by x minus 9, x minus 1. By both things. Because look what happens, okay? Here, the x minus 9s cancel. Here, the x minus 1s cancel. And then here, they both cancel. Okay? So what I'm left with now is I'm going to write what I have left. So in my first term, I have 7, and then the x minus 1. In the next term, I'm going to write it in parentheses. I have x plus 5 times x minus 9. And then my last term, I have 2. Now to simplify this part right here, I need to box. I need to box method this. Oops, this is a negative 9. That could have been bad. I can combine these. So I have x squared minus 4x minus 45. And then this, obviously, I'm going to just distribute. So I end up having 7x minus 7. Now I'm going to write this. Plus x squared minus 4x minus 45 equals 2. Let's combine like terms. So I'm going to write the x squared first because that's how I usually see it. 7x minus 4x is positive 3x. Negative 7 minus 45 is negative 52, and that equals 2. I'm going to then subtract 2 on both sides. That's going to give me x squared plus 3x minus 54 equals 0. So at this point, you're going to factor using some product. I'm not going to finish this problem, okay? Because that's going to take up too much time. But you could finish it on your own if you want to. If you want to try it, you should get x equals negative 9 and x equals 6, okay? One last example. I promise, okay? So one last example that I'm going to show. I just want to show you guys when there is an extraneous solution, okay? So this one has an example of an extraneous solution. Okay? So I'll try to go through this one quick. 7 over x plus 5 plus 5 over x minus 5 equals x over x minus 5. Okay. First denominator I see is x plus 5. Cancel, cancel. So I have 7 plus, I'm going to distribute this because why not? Same with the next one. And then I have another denominator, x minus 5, x minus 5, x minus 5. I'm going to cancel, 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 cancel. So that's going to give me, I'm going to distribute this, 7x minus 35 plus 5x plus 25 equals x squared plus 5x. I'm going to combine like terms. So I'm going to have 12x minus 10 equals x squared plus 5x. I'm going to move everything to one side, right? We should know how to do this now. It's a lot of work, but we're almost there. My hand hurts. Okay, I have x squared minus 7x plus 10 equals 0. Okay, find factor pairs of 10. 5 and 2. Both have to be negative. So I have x minus 5, x minus 2 equals 0. We know our shortcuts, right? X equals 5, x equals 2. Okay? Let's go back to the original problem. Look at our two denominators. We had x plus 5 and x minus 5. If I were to plug in 5 into the second denominator, into this one right here, I would get 5 minus 5, and that's going to be 0. That is a problem. That means this is an extraneous solution. We don't like it. It's fake. So our only solution is x equals 2. Oh my God. Okay, that was a lot. But those are just 3 kind of examples of different types of problems that you may see. Do the practice, then we're done with this.